All right, lesson 5.4 is review from Algebra 1 in geometry, and we're going to go back and talk about factoring. Now remember that factoring and foiling or distributive property are really opposite operations. You are undoing the multiplication. You're basically breaking it back up into the factors. So when you were little and we said, what are the factors of 12? You said, well, 12 is 1 times 12, and it's 2 times 6, and it's 3 times 4. Well, now our numbers are more complicated. They have squares and they have variables in them. But that idea of breaking something that has been multiplied together back into its pieces is what factoring is. This table right here, I'm going to give you in a cheat sheet for the test, but you do need to know how to use it. So the first thing that we talk about when we factor, the first thing we always look for is a greatest common factor. It's that one number that every single piece, every monomial, has in it. So when I look at a cubed b squared, 2a squared b minus 4ab squared, what do they have in common? Well, there's no coefficients that are the same. A cubed, a squared, a. They all have an a. So I'm going to pull that out. B squared, b squared, they all have a b. When I pull it out, remember I'm undoing that multiplication. So I'm going to divide. If I take 1a and 1b out of a cubed b squared, I'm left with a squared b. If I take 1a and 1b out of 2a squared b, the 2 is left, 1a is left, but the b is gone. If I take ab out of 4ab squared, the 4 is left, the a is gone, and 1b. And so this is what you're left with. Now, these next three, difference of two perfect squares you had in geometry and algebra 1. A squared minus b squared always factors into the square root plus the square root and the square root minus the square root. And if you FOIL that, what you find is your inside and your outside terms cancel. It's positive BA and negative BA. And that's why there's no AB term. The sum and difference of cubes you haven't had before, but again, they're a pattern. If you have a cubed plus b cubed, so where a is really the base, think about a and b are the base. What happens if you have a plus here is you have the base plus the base times the quantity of the base squared minus the two bases times each other plus the base squared. And then kind of the reverse happens when you subtract them. You subtract the bases, square of the first base plus the two bases plus the square of the second base. We're going to do examples. Perfect square trinomials you don't really need to know because these, if you remember, literally mean this, and you can FOIL them. But if you recognize the pattern that the quantity a plus b, the quantity squared, is always the square of the first term plus twice the product of the two plus the square of the last. That one's not quite as important. General trinomials, this is really our FOIL factoring option. And we'll go through that in a minute. Grouping is if you have 4 or more items in your list, 4 or more terms, what we're usually going to do is we're going to group the first 2 and the last 2. Look for greatest common factor. So in here we had x, we had y, and then what happens is that this piece becomes a greatest common factor again, so I pull that out, and then this is what's left. And we did some of that in algebra and geometry also. So let's look at some examples. So the first example is greatest common factor. So when I look at 10a cubed b squared plus 15a squared b minus 5ab cubed, what do they all have in common? Well, 10, 15, and 5 all have a 5 in common. When I look at a cubed, a squared, and a, there's at least an a in every one. And when I look at b squared, b, and b cubed, there is a b in every one. When I take those out, 10 divided by 5 leaves 2. A cubed divided by a leaves a squared. B squared divided by b is b. Plus 15 divided by 5 is 3. A squared divided by a is a. B divided by b is 1, so that's gone. Minus 5 divided by 5 is 1. A divided by a is 1. B cubed divided by b is b squared. So that is factored. You can check your problem by doing the distributive property. And if you go in and you do the distributive property, you should get that answer back again. Now, if we are going to go ahead and factor by grouping, I'm just going to go ahead and I'm careful with this negative, I'm going to say plus a negative 2, and I'm going to group them right here. So, this first one, what does x cubed plus 5x squared have in common? Well, they both have an x squared, and so that leaves x plus 5. Plus, what do negative 2x and negative 10 have in common? They have a negative 2 in common. Watch your signs. Now what happened is remember parentheses, this is one number, and this is one number, happens to be the same factor. In your brain, you could think that this is x squared times a plus negative 2 times a, because this is one number. In this case, you'd factor the a as a greatest common factor out, and you'd be left with that. Having x plus 5 as your greatest common factor, if I divide x plus 5 times x squared by x plus 5, x squared is left. And so this is completely factored. You would check this with FOIL. If you FOILed this, you would end up back where we started. Let's look at another factoring example. If again I have 4 terms, I'm going to group like this. A cubed minus 4a squared has a common factor of a squared. A minus 4 plus 3a minus 12 has a common factor of 3. Now, a minus 4 is a common factor in both of them, so I pull a minus 4 out, and I'm left with a squared plus 3. Again, you can check with the FOIL. And so just real quick, I'll show you to check it. First two terms times each other. A times a squared is a cubed. Outside terms plus 3a. Inside terms minus 4a squared. Last terms minus 12. And that's exactly what we have here, even if it's in a little bit different order. So it does work. You're undoing that operation. Now, this page is your review page. This is where the foiling and the factoring are opposite operations. This table right here is one that you really want to memorize. It's one you really want to know and understand, because that's how we know which order, given our trinomial, our 3-term thing, if those are our signs, these are the signs of our factors. Now I'm going to take a little break here, and I'm going to go to a blank page, and I'm going to show you something. So let's take something like x plus 5 times x minus 7. If I FOIL this, first two terms, x squared, outside terms, negative 7x, inside terms, plus 5x, last terms, minus 35. Outside and inside always combine. So when we say, so the directions this way are to simplify. The directions this way say factor. And I want to undo, I want to find out what two numbers were multiplied together to make this number. Okay, so this is what we're working at. So what's going to happen is we're going to get this problem where we'll say, well, what two numbers were multiplied together to make this? Well, I need an x in each one. It's minus, minus, so it's one sign of each. And then we use these last two numbers because the factors of the last number, because those two numbers here need to make negative 35. So I look at the factors of 35, which are 1 and 35, and 5 and 7. Now in the old days of trial and error, we would put the 1 in here and the 35 in here, and then we would check. Outside, minus 35x, inside, x, well that leaves me minus 34x, which isn't anywhere near 2. And so that isn't going to work. And even if I switch them around, I'm just going to get a positive 34. So then I know that I need to try, well, let's put 7 and 5 in here. And when I check my outside and my inside terms then, my outside two terms are negative 5x. My inside two terms are positive 7x, which is a positive 2x, which is close. So all I have to do at that point is switch my signs. And then I have what I need. And if you notice, I basically ended back up where I started, which is the whole point. Now these are fairly easy when there's no term in front of the x. So let's start with something that has a term in front. So what happens when I have something like 5x squared minus 13x plus 6, where now I have to worry about terms in front of the x squared and from the 6? Well, we still start the same. Minus plus is minus, minus, and I obviously have an x in each one. Now remember how this term got built. That term gets built by multiplying the first two terms together. So that's where the factors of 5 have to go. The 6 comes from multiplying the factors in the last position together. So the factors of 6 have to go in the last position. So I always make a list. So I have 1 times 5, and I have 1 times 6, and 2 times 3. And I'm going to go through outside plus inside combination. Since I have two negatives, I'm really adding. So I'm going to take one factor from the 5, multiply it times one factor from this last position. This is my first position, my last position, and I'm going to add to it the other two factors. Okay, that's going to be 31, which is not 13. And then I'm going to switch it. 1 times 6 plus 5 times 1 is 11. That's not 13. So that one can't be it. So then I'm going to do 1 times 2 plus 5 times 3. Well, that's 17. So that doesn't work. So then I do 1 times 3 plus 5 times 2. That's 13. These are the numbers I need to use. So what I need to do is I need to put these two factors of 5 in here. Now remember, it's outside and inside. So here, my 5 needed to get multiplied by the 2. And my 1 and 3 need to get multiplied. When I check my outside and inside, I have negative 3x, negative 10x, which is negative 13x. That's what I need. Check your first two terms. X times 5x is 5x squared. Check your last two terms. Negative 2 times negative 3 is negative 6. I'm going to go back to the regular lesson in part 2 of this video.